difficult than the previous one because we don't have an x to get rid of to move on the other side, but also y is not y, it's minus 3y. So you can see I've written the answer. You should be able to get from 2x minus 3y equals 9 to y equals 2/3 x minus 3. The step is shown. You should be able to do that without even peeking at the screen. Now we have a slope of 2/3. Again, we've introduced a new little bit of complexity. We have a fractional slope. That shouldn't make much of a difference. Hopefully we all can deal with 2/3. We really don't care that the equation is y equals 2/3 x minus 3. We just care that the slope is 2/3. We found the equation to find that slope. So we know, as indicated on the visual, that if the slope of the line is 2/3, the slope of the line perpendicular to it is the negative reciprocal, or negative 3/2. Okay. The next visual completes the problem. We have the slope, negative 3/2. We have the point on that line, negative 2, 5. We replace the x with negative 2, the y with 5, and we solve for b, the y-intercept, which turns out to be 2. And this time we write the correct equation, y equals negative 3/2 x plus 2. And of course, if we replace the x with the negative 2, we get a y of 5. 3 plus 2 is 5, so it does check. And again, it's important to check. Even though using the same point is the only one we have, it's better than nothing. And as you saw in the previous problem, if you make a careless error, checking might save you from getting points taken off on your test. Okay, so now we've looked at finding the equation of a line given 2 points. We found how to find the equation of a line given a point on that line and a line parallel to the line in question. We found out how to find the equation of a line if you're given up 1 point on the line and you are told the 2 lines are perpendicular. What I'd like to do now, in the time we have left in this lesson, is to look at the steps, and I'd like you to write these down. And then maybe we'll take a look at a problem or two, depending on how much time we have left, to demonstrate, again, the use of these steps. And the next visual shows us the 4 steps. And these are steps that I use in my classes. I demand that my students follow these steps. I think to me, it's very good methodology to follow steps that work. The first step is to find the slope. If you're given 2 points, you find the slope by looking at the difference in y over the difference in x, finding the slope. If you're given a line and told it's parallel to the line whose equation you want to find, what do? You take that equation, you get it in y equals mx plus b form, and you have the slope. And since the lines are parallel, the slope of the unknown line is the same as the slope of the given line. If you're told 2 lines are perpendicular, you again get the line whose equation you're given in y equals mx plus b form. You have m, and you know that the slope of the perpendicular line is the negative reciprocal. So if the slope of the line you have is negative 5, the slope of the line you're trying to find the equation for will be positive 1/5. The negative reciprocal of negative 5 will be positive 1/5. Then you substitute coordinates of a given point to solve for b. Substitute coordinates. You're given at least 1 point. If you're given 2 points, pick one. I was given the choice of a point that had a negative number in it and a point that had 2 positive numbers. I chose the 2 positive numbers. Replace the x and the y and the m in y equals mx plus b. Because remember, in step 1, you found m. You now have the point, you have x and y, you solve for b. The third step, which a lot of people leave out, and again, when my students, if they leave it out, they don't get full credit because the problem asks for the equation of the line. Write the equation. Write the equation of the line, and then check. If you're given 2 points, check with the point you did not use in step 2. If you give it only 1 point, that's the only point that you can check with. Well, let's take a look at a typical problem. Let me go ahead to the board. And let's say we had a problem, and I'm going to ask you some questions along the way to see how you think I would do this. Let's say we had a point, -3, negative 4 was our 1 point. And the other point on this line was, oh, let's say 2 and 6. Does that look good? That looks like a good set of points. Now, how do I know it's good? You'll see why. First thing, what do I do first? Well, again, hopefully you wrote down the steps you saw, and that was the first thing I want to do is get the slope. Since I'm not told anything about parallel or perpendicular lines, what I need to do is find the slope arithmetically. So I'm going to take the y over here, 6, and subtract the y over here, minus 4. And again, I'll repeat this again because some students think one minus sign is enough. Nope. This minus means subtract. This is because we have a negative 4. And we divide that by the change in x. Since the 6 goes with the 2, 2 goes with the 6. And negative 3, minus a negative 3. A little addition, and this was or subtraction. Remembering back to 7th or 8th grade when you worked with integers, this is quite important. You can do this. 6 minus negative 4 is 10. 2 minus a negative 3 is 5. And 10 over 5 is 2. The slope of this line is 2. Okay? The second step is to substitute the coordinates of 1 point to solve for b. Well, you know my next question is going to be, which point would I choose? If you say this point, you're wrong, and you haven't been paying attention. And I don't like you because I don't like negative numbers. So, those of you who hopefully said this point, I feel pretty good about because indeed that's what I would use. I like to use positive whole numbers wherever possible. Okay? So let's say now y equals mx plus b. The y is 6. The m is 2. The x is also 2. 6 equals 4 plus b. Solving for b, we get 2. So, y equals m, 2x plus b. A nice little equation. Notice that both the m and b are 2. Is that important? Only that it's correct, I hope, for this equation, but otherwise it just was nice to get a slope and a y-intercept that are the same. Different meanings. Remember, this is how much y changes if x increases by 1, and 2 is where the line crosses the y-axis. Now we need to check. How should we check? Well, we're going to have to work with those negative numbers. We place them into the equation. Y, negative 4, let's see, equals 2 times negative 3 plus 2. And the checking is indicated by if the left and right side are indeed the same value. Negative 4 equals negative 6 plus 2. Negative 6 plus 2 is negative 4. It checks. So, the answer to the problem, y equals 2x plus 2, is the only possible equation of the line that contains those 2 points. Now, why is this important? We said before that we had to be able to deal with lines as models for real-world situations. What if the model you had, the information you had, you only had 2 points? You had gone out and collected, and all you had was 2 pieces of data. This would be a way to write the equation. It might be a weak situation, but it would be the only thing you had. If you were dealing in calculus, when we get to calculus sometime in the future, one of the things you'll do very early on to develop the notion of what's called the derivative, which is the cornerstone of calculus, is to look at the slope of a very special line. And in that very special line, instead of using numbers, we're using letters, variables, symbols. Obviously, you cannot work with letter symbols if you can't work with numbers. So doing a problem like this is quite important. Okay? Now, we haven't done another problem with parallel or perpendicular. I think those, to me, are much easier. The only difficult part, possibly, if you're given an equation like 5x plus 7y equals 9, writing that in y equals mx plus b form to get the slope of the given line. Because remember, if you have two parallel lines, their slopes are the same. if you have perpendicular lines, the slope of one line is the negative reciprocal of the other line. Now, the next thing we're going to do in the next lesson is graphing linear equations. And I want to relate that to what we've done today so you can be mentally prepared when you flip on your VCR to do what we're going to do. We've done today was, hey, here's some information about an equation. Maybe here's a picture of the line, or here's some points on the line, or here's a line parallel to it, or perpendicular to it. Find the equation. We're going to turn that around in Lesson 8. In Lesson 8, we're going to look at, hey, here's the line, here's the equation. Find the line, draw the line, find the points, show the slope. Use the slope to draw the line. Use the slope to find out something about the y-intercept, x-intercept. Use the x and y-intercepts to find the slope. Using all the things we've done in the previous two lessons, putting them together to be able to talk about graphing linear equations. And remember, all of this is important because the real world has many things that are linear, many things that are approximated by a line. And so therefore, as we know how to use the equation of a line, we're able to apply situations in which things are changing at a constant rate. Because again, another way of looking at slope is the slope means that things are changing at a constant rate. Before we go, let me give you one thing to think about. And that is, imagine you were traveling in a car and you were traveling at a constant speed of 45 miles an hour. What would that mean? It would mean that every hour you went 45 miles. Every 2 hours you went 90 miles. And if you graphed hours on the x-axis and miles on the y-axis, what would your graph look like? Your graph would look like a line whose slope was 45. Because every hour you increased, every time you increased x by 1 hour, because your slope was 45 miles an hour, you'd increase your distance traveled by 45 miles. There's a very common practical example of the use of slope in the real world. So we'll see you next time in Lesson 8, which will be on graphing linear equations.